The notion of actuator can go beyond man-made systems and enter the biological kingdom. In a biolab at MIT, we are growing our own natto cell actuators. Natto cells were found 1,000 years ago by a Japanese samurai, and since then it has been used to ferment natto food in Japan. In this project, we utilize this Asian bacteria in a new way. It becomes a nano actuator that expands and shrinks based on different relative humidity conditions, such as the humidity level in the atmosphere or the sweatness of the skin.
Cell is conventionally considered as a factory for producing chemicals, but its own mechanical properties is always neglected. Here, we are looking at its unique cellular structure. By absorbing or releasing moisture from its intracellular components, cell can swell or shrink in a second. We culture our own cell in bioreactors. One cell can turn into 10 billion cells overnight. This enables us for fabricating large volume cells in a short time for potential industrial applications.
The question now is, how can we translate the expansion and contraction of the cells into new type of transformations that we want? We started to build up an automatic printing system in which fresh cell can be assembled on a thin fabric. The different expansion and contraction level of the two materials creates a variety of bending behavior in space and time. Here, the biological and digital fabrication processes are united together to synthesize a responsive biohybrid material.
We create our biohybrid film through a printing process. With the micron printing resolution, we are able to align the cells along a certain orientation. The alignments create a hierarchical structure which helps us to program the specific transformational behaviors that we hope.
The biohybrid films coming freshly out of the printer can be integrated into traditional fabric. This way, the composite materials still holds the function of reacting to the skin and transforming. However, it becomes much easier to handle for the garment production.
In this project, we are trying to create an interactive feedback loop among human body, biofilm, and the environment. During the research process, we always need to modify the material properties based on our experimental data. And we have to use these properties to explore all the design possibilities of our biofilm. Therefore, we build a design interface which can not only simulate material behavior, but more importantly, give the designers a real-time feedback, creating a seamless connection from experiment to design to fabrication.
In this time, fashion is changing, and this project is part of it. I believe it's time we rethink the way we create fashion and the reasons behind it. Biologic project enables us to explore new innovative materials combined with traditional garment making techniques. The designs are inspired by the natto cell's response to different body parts, and that creates really fine, flat movements. The experience of wearing these garments is very special because they come to life once you start wearing them.
In addition to a single bending structure, different printing patterns and material combinations enable us to create more complex transformations. If we embed heating circuits into the substrate, the material gets controllable through electronic signals. And looking beyond the cell's mechanical transformation, we can imagine to incorporate additional functions produced by the cell itself, such as color change, and that opens up a quite big variety of future applications.
We always find the opportunities in conflict between disciplines. We deconstruct old paradigms to create new archetypes. That's transdisciplinary. We are very much excited about this biologic project and potential paradigm shift from building to growing.